Yes, thanks for the introduction. Some of you may know me, some of you may not know me. As Phil mentioned, I'm PJ. The company where I work, you may or may not know as well. We're, of course, mostly known for TeoPlayer, which is basically our suite of media player SDKs. And, of course, as a vendor, we have to be compatible with basically everything that our customers want to use, infinite numbers of combinations, all kinds of different parameters used in streaming protocols. And of course, well, as a result, we always have to be more or less on the edge of what is possible and what is available. The same actually happened, of course, with low latency HLS. So that's something that we're going to talk about today. We followed a bit of an odd track, I think. The journey we did implementing low latency HLS was quite long, a lot longer than most will think or most will know. And when I was actually thinking about it, what I would talk about today, I figured there are two things that are probably the most valuable to talk about. On one side, the road and the history that we took to actually get a version ready to launch for low latency HLS. It was quite a journey, as I already mentioned. And beyond that, I think it's also valuable to talk about probably the topic talked about most when talking low latency. It's ABR, but not just ABR with low latency HLS. There has been a lot of talks on ABR and keeping a high QoE for low latency. But for low latency HLS, it's actually quite different. There are a few very big differences compared to low latency Dash. And I think that it's definitely worth highlighting some of those. So let's dive in. The history part. So most people probably think that an implementation of low latency HLS went something like this. You had in June 2019, you had WWDC, where Apple announced that low latency HLS was going to be a thing. They published a document with a guide that you could already do, some showcases, and that was it. They launched it on iOS as a beta that you could start testing it out. And then in January 2020, they decided that the approach that they had taken, which was using HTTP to push, was not the approach that they were going to take in the end, but they changed the specification to support preload hints. And then in June of 2020, they more or less confirmed that that was going to be the spec that they would go with on iOS 14, which then in September, they actually shipped. And the HLS specification was updated to reflect those changes. And for most low latency HLS implementations, they probably started after June or even September. For us, that wasn't really the case. For us, the story with low latency for HLS actually started a lot earlier than that. Because something that most people don't know is actually that the story for us started about 5 years ago. Because back in early 2016, we were working together with Periscope. Low latency being one of their USPs, they had modified HLS to do the progressive downloads, chunk transfer encode, which most of you probably know later became the foundation of what is known as the LL-HLS variant, where those segments are actually streamed progressively. We were actually working together with Periscope to further optimize this and providing a player solution for web. What we actually did was we actually announced that on November in 2016. We actually did a talk on Streaming Media West. It went quite under the radar still at the time. And it was also quite difficult, I must admit, because there were a lot of things under like confidentiality agreements that we couldn't disclose yet. But well, we had some pretty good reactions. The nice thing was actually 1 year later, more or less, in July 2017, when Periscope decided it's time to actually start sharing some of the technical details, how we're doing this. And they actually made some of that stuff available. It was very early days back then, but we bumped into quite a lot of issues that most people working on players and low latency probably are familiar with. Data being sent over the network, idle periods being introduced in between chunks. which of course forced us to rethink things like bandwidth measurement and ABR, something which a lot of people bumped into with low latency Dash as well. But also something that was, well, quite uncommon back at that time. The data actually had to be piped down to the decoders as fast as possible. In the past, most players, what they would do is they would actually just download an entire segment. When that was finished, send it into a buffer, and yeah, just handle it as well, small chunks of video basically, but not that small that you would send them through immediately after a few bytes were received. Beyond that, things like the buffers being squeezed as much as possible. If you go into like a no mercy scenario when it comes to network instabilities, of course not good, because you need to get that QoE and keep that QoE as high as possible. But also like startup strategies we were considering back in the day. Would we go for like the last known segment, which would mean a faster startup but a higher latency, or should we wait for like the next segment to come and then pick up when it would become available to have like the lowest possible latency at startup, but a slightly higher startup time? And then something that's quite common these days, like the catch-up algorithms, in case of a stall, in case of a slow startup, in case of being even too close to live. So all of the algorithms to, well, slow down or speed up to attempt and reach the latencies that were ideal. Probably doesn't sound that thrilling anymore these days, given that a lot of companies went through this for low latency Dash as well. But back then, back in 2016, it was definitely a pretty big challenge. It was not something that people had done before us. It was a lot of figuring out how we could do this. But it was actually back then that we put in place most of the groundwork of what not just became our low latency HLS implementation, but also a lot of the other low latency protocol implementations that we did between 2016 and now. Not too long after 2017, well, in 2018, low latency actually got more attention. It was the year that low latency Dash actually became a thing. And in parallel, there were some backroom conversations about what later would become low latency HLS. But all of that actually happened before the entire WWDC story. Because after that, WWDC happened. And then, of course, back at that time, the way to do it was with H2 push. It surprised quite a lot of us, I think, that they actually went for that approach in the end. But because it was a first, well, ratification of Apple starting to first publicly communicate back in 2019, we actually started to implement our first low latency HLS pipeline. And we figured it would take about a year before Apple would actually go live and then put it in iOS in a way that it wouldn't be like a test version. So that would give us quite some time to be ready before and to really validate it before it would really become a thing. So we implemented it. We actually set up a new pipeline. We wanted not just our main loop to do what we did in the past with parallel manifests or playlists and segments, but really just one loop, fetching playlists and in parallel, well, not in parallel, but thanks to the H2 push, getting in the segments or the parts as well. It was very fun in January. We actually had a first version available. I remember it quite well, I must say. I was sitting in a hotel room. It was during CES. I just got shipped the version of our player, was going to get the seal of approval so that we could move along with it. And exactly on that day, the day when I was testing in that hotel room, an update, an email, hey, we're going to switch the H2 push version. We're going to announce that we're going to start using preload hints. Where, well, no longer push, but instead the blocking requests that HLS is now using for the low latency capabilities. And of course, those preload hints, they reminded us a lot of the work that we had done with Periscope. It was quite painful though, because of course we had done a lot of work to make sure that we would be compatible with push. All kinds of weird cases, bandwidth measurements really being a very big problem at that time. But yeah, I mean, the spec was being changed. So we threw a lot of that work out, I must say. And we started over and, well, we implemented the specification that we now all know as low latency HLS. We did make it in time for launch end of August. It was at first a minimalistic implementation. We had ABR, alternative audio tracks, but DRM, subtitles, things like discontinuities, we didn't have ready to go in time for August, but we actually added those after that initial release. So that's probably a slightly longer history lesson than I originally thought that I would give. But it felt necessary because, well, we tackled actually quite a lot of those problems way before we had the preload hint version of LL-HLS. In fact, actually, the most of our development and most of our initial digging, trying to figure out how we could do all kinds of things, happened way before that. By the time that the AXTX preload hint version got known, most of the problems that we had to do research on actually had already been solved by our team, at least. So let's dive into, away from the history and a little bit more into the technical bits. And to do that, as I mentioned, the ABR part, and especially also the question that usually goes hand in hand, the bandwidth measurements, how do they work? In the past, we all know this, but I'll briefly explain. Very simple. You would have a segment. It's in HLS, always entirely available on the origin. When it's published into a playlist, you know that you can get it completely at line speed. So you can basically record the time when you start the request, when the response ends, and, you have the duration of your request, and you basically divide the number of downloaded bytes by that duration, and, you have a pretty good speed estimate. Simple, efficient, and it works. Now for low latency HLS, every part is made completely available when it is published in a playlist update. So you would think that it remains very simple, but of course there is one significant problem. It's a problem that even in low latency Dash you don't have. It is the blocking response. It's not a bad thing, but something that you need to keep in mind when you are doing low latency HLS properly. Preload hints is actually the way how you load most of your data. A player normally will have 2 requests pending, 1 request for the next playlist update, 1 request which is basically blocked until that data arrives, which is the preload hint request, or preload hint requests multiple, because you can have, of course, multiple for audio, video, or even map files, all being launched in parallel. Simply using here the request start minus, or the request end minus the request start, it will no longer work. You will basically get something that is very close to the media bandwidth that is actually being used, so the bitrate of the actual encode. But something that you can do, especially in browser environments where it's usually the hardest to get these kind of estimates, you can know when that first chunk of data arrives. So you can basically, instead of going from the start of the request, you can just take the end of the response minus the time when the first chunk of data arrived, and then basically count all of the data that arrived since that point in time, and that will work. If you have bad luck, you will, however, only get 1 chunk, and there are a lot of cases which can muddy the waters here. So I must admit, this is a simplified representation. A lot of browsers, they will do some nasty things. Usually, most browsers, they will chunk it up and send it out in a nice way. But there's quite a lot of rechunking possibly going on. But let's keep that away for now. Let's assume that it's a simple setup. You get nice chunks in your environment. It's all rainbows and unicorns, because otherwise we would end up going pretty deep, I think. But basically, for low latency HLS, you need to change the bandwidth measurement. Not too much, but there is, well, it feels easy, but there's another problem. And that other problem is basically what happens if you start using byte ranges. In normal low latency HLS, you do have the named parts, and for every part, you can just issue your own request. But if you're using byte ranges, it's just not efficient to do that. It's way better to keep that request open. Shutting it down, it's just wasteful. The disadvantage is that if you have multiple parts and every one of those is published at line speed, there is the blocking time in between. You know that this is also one of the hard problems that was solved for low latency dash. And well, we had already solved low latency dash when we started doing low latency HLS. There are all kinds of other cases how you can ever go at it for low latency HLS. But the solutions that low latency dash by default uses, they did seem to be lacking. The estimates for us, they felt slow to respond. They're not very good in case your network suddenly crashes. They're far from accurate. And we were considering, well, can't we do this in a better way for low latency HLS? And well, the answer is you can. What you actually have as a very big advantage in low latency HLS is that you know which bytes are being transferred at line speed. It is just announced in your playlist updates. So when a part is being transmitted, you get that first chunk of data, but you also get that playlist update in that parallel playlist request. And well, that will contain the exact start and end bytes from the part that's being bursted. If you record those times, log down when that start byte actually arrives, you can actually identify where these bursts all start and end. You don't need to do any low-pass filtering or any trickery to start, well, estimating a bandwidth, because there's a better way to do it. As I mentioned already, there are still some problems with some browsers, potentially holding like the first and last chunk and keeping them longer than they should because they want to fill a buffer before they burst it through to the application. This can also happen on network caches. There is a lot of complexity that gets added to it. But, well, as a rule, let's just believe in rainbows and unicorns. If you really want to handle all of those use cases, it will become quite complex. Admittedly, this is not really the way how we ended up doing our bandwidth calculation. This is one of the steps that we took, but we actually use a mix of different heuristics. This heuristic that I just explained, it gives you quite a good bandwidth estimate. There are some corner cases, as I already mentioned, so not always the best approach, especially when the network is crashing. You need to respond very fast. In those cases, yeah, low latency HLS, you have extremely small buffers, so there usually isn't much time to actually do a switch. And well, with HLS, it's actually very important to keep in mind a few other things, because a client has to do quite a lot when an ABR switch actually has to be performed. It always seems very simple for everybody. You check if you have enough bandwidth. If you do, then that's great. If you don't, then you switch down. It's all very simple. In HLS, it's not really that simple. Why? If you want to switch, it means that you need to download a new playlist. Low latency HLS, it means you need to have an up-to-date playlist, which luckily you can get with the EXTX rendition reports. But even then, there's some round-trip times that you need. And well, it's actually another problem. It's only after you've loaded a renditions playlist that you know where you should start loading. in a happy HLS scenario, you can load the next segment. If that segment starts with an independent frame, you're all good. But very often that's unfortunately not the case. If there are any packaging vendors listening, really, please fix this. Get your segments with a keyframe at the start. It's not that hard, but it makes life for us a lot simpler. In low latency HLS, there's actually another thing which is very tricky. You could look for something that is marked as an independent part. But if you read the spec very well, independent on a part doesn't mean that that part starts with a keyframe. It means that that part contains a keyframe. It's right there in the spec. A lot of people assume that it's actually starting, but definitely not the case. Even beyond that, even if you know which part is the right part to start, you still don't have in HLS a reference of the presentation times. With Dash, you do have those. With HLS, you don't. Sometimes you need to just pick a part or pick a segment, go with it, pray for the best. Not always very happy. But, well, it's the good news is actually that in low latency HLS, the program date time was made mandatory. It gives you a reasonable effort, or at least gives you a reasonable estimate. It makes things a lot simpler. But what does that actually mean for our flow? You can get the playlist. You can sync it with your timeline. You can start to identify the independent parts. There is still going to be some praying that you need to do. If you assume that it's the happy path, it will all be okay. But if that independent frame is not at the start, it's somewhere behind your buffer, you will create a gap. You might need to retrace your steps, and you will probably need to do it very fast, because all of these steps, there is network communication needed. It will take time. It's not very good because, of course, if you take the wrong guess, that's a stall. If you're too careful, you'll probably switch down to a quality which is way too low. Also not very good because then, well, you could have gotten a better QoE. But while all of that would be extremely interesting, maybe I should submit a DMAX talk for this. But, well, I am afraid that Phil will very soon get the broomstick and kick me off because I'm seeing that we're nearing the end of our slot. So, as mentioned already, a lot of different aspects in implementing low latency HLS. We've just talked about ABR, a lot of other things to actually talk about. But let's dive into questions if we have any time.